Good day, ladies and gentlemen. Today we'll now look at a type 3 kind of a problem, and we know that in type 3 we have now an object that is thrown upwards from a building or some particular height, and then the object will now be thrown up from a building, and it will pass the point of projection, meaning that where it was thrown up, and then the object will hit the ground. In this case, ladies and gentlemen, what we are trying to say is that the object was thrown upwards from a building, a height of a building, and then this object, instead of going back to the thrower's hand, it now passes the thrower's hand, and then it will now do what? It will now hit the ground. Now, in this case, we all know that for us to solve this problem of ours, we will then need a trajectory. A trajectory is simply a sketch which now shows us the motion of an object. Here I will have my ground, and then the object here is the building. The building will have now height h. There is the height of the building, and then a person will be standing here and throws an object upwards. The object will go upwards, reach maximum height, and then pass the point of projection, and then the object now goes to the ground. That is now my trajectory, and we know that we need now to label all the important parts from our trajectory. From the point of projection, I will have point A, and then where it reaches maximum height, I will have point B, and then where it passes the point of projection, I will call that point C, and then where it hits the ground, I will then call that point D. That is now my trajectory. And me drawing this trajectory, I need now to talk about each and every point that now appears on my trajectory. Then if now I were to talk about point A, at point A we know that the velocity at A is greater than 0 meters per second, because the object was thrown. So meaning when the object is thrown, the velocity at A will be greater than 0. And then if I were now to talk about the velocity at point B, we know that at B, that's where the projectile reaches now maximum height. And when it reaches maximum height, we know that the velocity at B will be equals to 0 meters per second, because that's where now the object is going to change direction and then go downwards. And then we can further now talk of the velocity at point C. We can see that the velocity at point C, the projectile is exactly now as it was at point A. So the velocity at C will be equals to the velocity at A, but in what only? In magnitude only. the velocity at C will be equal to the velocity at A, but in magnitude only. Then we'll talk now of point D. At point D, we know that because the projectile is now going downwards, we know that the velocity at D increases. The velocity at D increases as the projectile approaches point D. The velocity at D will now increase as the projectile approaches point D, meaning that the velocity at C is less than the velocity at D, right? And then what else can we talk about? We can now talk of the motion. Let's talk about the motion from A to B. From A to B, what is it that we know about the motion? We know that from A to B, we know that T at A, B will be equals to T at B to C, because now we can see now from A to B and B to C, we have now the same displacement. From A to B, we have the same displacement, and we know that when we have the same displacement, time from A to B will be equals to the time from B to C. So it simply says now, when I look at the motion from B to C, it simply says now from B to C, the time from B to C will also be equals to the time from A to B. And then we know the reason why we say that it's because of now symmetry. A to B is symmetrical to B to C. So the time it takes the object to move from A to B is the same time it takes the object to move from B to C. And also, there is now something that we can also talk about from A to B. We know that the displacement, which is the height from A to B, will be equals to the displacement, which is the height from B to C. We know that the height from A to B is equals to the height of B and C. So delta YAB will be equals to delta BC. Right, ladies and gentlemen, I hope we are still together now. And we know that if now the examiner was to ask me about the displacement from A to C, will be equals to 0 meters. 0 meters from A to C, because we know that the displacement from YAC is equals to the displacement from A, B plus the displacement from B, C. And we know that the displacement is a vector quantity, meaning that it has direction and magnitude. I hope now everything now is clear. The very important thing now for us is now drawing this trajectory of ours, to show that from A to B, the velocity of an object is decreasing, because now I can see the object is going upwards, and as it moves from B to C, the velocity is still increasing, and from C to D, that's then we'll have now the maximum velocity as the ball now goes downwards. And we know that the velocity of an object increases downwards, right? Ladies and gentlemen, I think now we can go now and look at a problem, an example. Let's now look at an example of this type 3 problem. Now the example that we'll look at is, now let's look at an example, and also now how to approach this type of a problem. We know that the steps, let's look at first the steps for solving a projectile motion. Steps for solving a projectile motion. Before we look at this example, I want us to look at the steps of solving a projectile motion, any projectile motion. It then says to me, step number one, after reading the scenario or looking at the diagram that the examiner has given us, we first have to now draw a trajectory. Draw a trajectory for yourself so that you can visualize the problem. Draw a trajectory. It simply means draw a sketch of now this projectile of ours. We draw a sketch, and then step number 2, after drawing a sketch, just now label your trajectory. Meaning that you label all the important steps, all the important points on your trajectory, all your important points on your trajectory. And then step number 3 says, after labeling your trajectory, choose your direction. Choose your direction. This one is very, very important. You need now to choose your direction. After choosing your direction, you will then say, let me assign all the vector quantities. Assign all the vector quantities their direction. Assign all the vector quantities their direction, meaning that you assign all the vector quantities their direction from the direction that you choose. And after that, that's then now you do what? You choose the correct equation. You choose the correct equation that will then help you to solve the particular problem. Let us now look at this example of ours, and then try and apply these steps that we talked about. Then it says the example here, in example 1, it states to us that a boy throws a stone a stone upwards. A boy throws a stone upwards from the top of a building. A boy throws a stone upwards from a top of a building at 10 meters per second. At 10 meters per second. And the stone strikes the ground. The stone strikes the ground at a velocity at let's say 20 meters per second. And then the question then says ignore the effects of friction. Ignore the effects of friction. Then it simply says now that this stone undergoes now a free fall. Then it says to us, after reading the scenario, from the scenario we can see that this boy throws a stone upwards from a top of a building, meaning that in my trajectory there I will have a building. In my trajectory I will have a building. They did not tell me about the height of the building, but I know that the building has a height. Then this boy of ours throws this stone vertically upwards, and then we know that this ball will eventually reach maximum height, and then after reaching maximum height, the ball now passes the point of projection and then strikes the ground. It strikes the ground, and we know that from our steps of solving a projectile motion, we first have to draw a trajectory. A trajectory simply tells us about a sketch that will help us to visualize the particular problem that we are faced with. And then it says label your trajectory. Now I have now to label my trajectory to say let point of projection be point A, and then let maximum height be point B, and where now the stone passes the point of projection, let's label that as point C, and then where now the stone strikes the ground, let's label that as point B. And then from there off, let's now look at our steps. Again. Our step says now, after labeling your trajectory, we can now go on further and say and talk about these individual points. Or now, what is it that I have at point A? At point A, I have now my V at A. I know that it is now what? It is now 10 meters per second. And then at point B, I know that V at B is equals to 0 meters per second. And then at point C, what is it that I have? I know that the velocity at point C is equals to the velocity at point A, which is just now 10 meters per per second. And what else did they give me? They gave me now the velocity at point D. To say the velocity at point D, the velocity at point D is equals to now 20 meters per second. Right, that is all the information that we have when we look at this trajectory of ours. So now let's now go on and say, now let's choose the positive direction, and then we must assign all the vector quantities their direction. Then it says to us, let me take now upward motion is positive. When I say the upward motion is positive, it simply says now my downward motion is negative. Then from this, that's then I can assign my vector quantities their respective direction. Let me look now at all my vector quantities. It says to me I have velocity at A, velocity at C. I will leave now the velocity at B, because the velocity at B is equals to 0. Then I will then take now the velocity at D. Then it says to me that if I chose my upward motion to be positive, and then the projectile at point A, it is now going up. It says now everything that now goes upwards must now be positive. And then from point B, that's where the object changes direction. And we know that at B, the velocity is equals to 0. And then at C, that's where now the object now goes downwards. When the object goes downwards and up is positive, it means everything that now goes downwards must be negative. And then also, because at D the object was still going down, or the stone was still going down, it says now the velocity at D must also be negative. And then from there off, I am done with the velocities. I can now go to the G, which is our gravitational acceleration. Now let's look at this. We then discussed that if upward is positive, downwards will be negative. And we know that G, it's the gravitational acceleration, and the gravitational acceleration acts downwards. And now when my up is positive, it says to me everything that goes downwards must be negative. And we know that G goes downwards, so the magnitude and direction of G will be negative 9,8 meters per second squared. I hope we are still following, ladies and gentlemen. Let's now talk about the displacement from A to B. The displacement from A to B. The displacement from A to B, because the object is still going up, in this case the displacement will be positive. And then from B to C, we are still talking about the displacement. From the displacement from B to C will be negative. We know that we talked that the displacement from A to B, this is just simply the height reached by the stone. And then even from B to C, we can say this is the height it took from B to C. That is our displacement, and it is negative because now it is now going downward. The object is now going down, and then we can say now that a delta y from C to D. From C to D, the object is still going downwards. When the object is still going downwards, we know that everything that goes downwards, it must be negative. It must be negative. I hope everything now is still clear. The time, we don't have to assign it a direction because we know time is a scalar quantity. And then from our steps here, it then says choose the correct equation. Then from there, the correct equation will now be chosen by now our question. Then question number 1 can say to us calculate the height at which the stone was thrown. Ladies and gentlemen, what is the examiner saying to us here? Let's now try and understand this question of ours. The examiner is saying that we must calculate the height at which the stone was thrown from. The stone was thrown from. What the examiner is saying is that we must calculate now this height that the stone was thrown from. It means now we must calculate the height of the building, and as you can see that the height of the building is equals to now CD, that is the height of the building. CD is the height of the building because as you can look from C, that is now from the top of the building, and D, that is where now, that is the ground. So the examiner is simply asking us to find this height of the building. So it says to us now, where are we looking at from our motion? What is it that we are looking at? Now there are so many ways now that one can calculate this height of the building. Someone can choose to say now, let me take now the motion from A to D, meaning the whole motion. But someone can also now choose to say, let me take the motion from C to D, from C to D. Let's say now, and then we'll look at this and look whether we get the same answer. We must then get the same answer using those points. Someone can choose the point C to D because these points C to D, we can see they are exactly equal to the height of the building. Now when we look at the point C to D, from C to D, what is it that I have? I have the velocity at C. I also have the velocity at D, which I will call the velocity at C the V initial, and then the velocity at D I will call it V final. Now what is the velocity at C? We then agreed that the velocity at C is equals to 10 meters. But now we first have to assign the direction of velocity of C. We saw that the velocity at C must be negative, meaning that it must now be negative 10 meters per second. And then let's look at the velocity at D. The velocity at D, we said now, is equals to 20 meters per second. And we assigned the direction of velocity of D to say now, let it be negative, because my upward motion was positive, meaning that my velocity at D, which is my final velocity, will now be 20 meters per second. Right, remember, for me to solve a projectile motion, I only need three variables. Now I only have two, but I always have this one, which is the magnitude of G. Remember, we talked of G, that G, we take it now from our choice of direction, and we concluded that if my upward motion is positive, G, because it acts downwards, it must be negative, and then we concluded that G must be negative 9,8 meters per second squared. And now let's now use this information to choose now our equation. Remember, from our equation we have this particular equation that says V final squared is equals to V initial squared plus 2E delta y. Now this equation of ours has the final velocity, the initial velocity, and then it has now A, which is the gravitational acceleration. From there I will be able now to find what? To find delta y. Let me go and substitute this. It says my final velocity, it's the velocity at D, which is now 20 meters per second squared, and then my velocity at C, which I will take it as my initial velocity, is equals to negative 10 squared plus now my 2 and my G. My G has to be negative 9,8 multiplied by delta y. From there off, we now need to take our calculator and then say to us now, what is 20 squared? 20 squared is equals to now 400 is equals to, and then 10 squared, we know that it is 100 plus negative 19,6 negative 19,6 delta y. Now I will then transpose now the 400, not the 400 but the 100. I will then transpose it, and then this side I will be left with negative 19,6 delta y, and then this will simply give me 300 is equals to negative 19 delta y. And then this is just a simple mathematical gymnastics where now I will divide by negative 90.6, and then I will find my delta y. Let's put that in the calculator to see now what does 300 divided by negative 19.6. It then gives us now the height of negative 15.30612245. Then it simply says now the displacement, the height of the building, it's just now 15.31 meters. Where, remember, this is the height from C to D, and then the negative shows us now this is downwards. Delta y will be downwards. But now the height will then conclude to say, therefore the height, remember here we were just finding the displacement. Delta y means the displacement, but the question then said find the height. So we then conclude to see the height of the building, it's 15.31 meters. Remember, the height doesn't have a direction. It's a scalar quantity. It does not have any direction. That's then I come and conclude to see the height. It must be 15.31 meters. And then here it is delta y. If the examiner said to you find the displacement, you will then say the displacement is 15.31 meters downwards. But now the examiner wants the height. The height is a scalar quantity, ladies and gentlemen. It does not have the direction. Can we now go on to another question? Another question, the examiner can come up with another question to say calculate the height of the stone above the ground. The height of the stone above the ground. And for that we now have to use now our trajectory to say now which height is the examiner looking for. Let's now go back to our trajectory on the previous page to look. It says now here is the ground. In the previous question, the examiner was looking for this, the height of the building, which is just the height from C to D, which we found now to be 15.31 meters. Okay, then the examiner wants now the height of the stone above the ground. Above the ground, ladies and gentlemen, you'll agree with me that above the ground, it must now be the height from BC and also the height from C to D, because here, that's where the stone is now above the ground. From this point, from B to D, this is the height above the ground, because my ground is here, ladies and gentlemen. And the examiner in the previous question told us now we must find the height of the building. But now we don't want the height of the building. We want the height above the ground. So above the ground, it says to me I must start at this point and then I must go from point D. Then it simply says now for me to calculate this height above the ground, I must first find the height from B to C. And then after finding the height from B to C, that's then I can combine it with the height from C to D. And then that will give me the height above the ground. Let's go, ladies and gentlemen, and look at this problem. We said now we will look at the height above the ground as the height from B to C plus then from C to D. This, ladies and gentlemen, will give me the height above ground. But already I have now the height from C to D. This trajectory of mine helps me now to see that I have now my height from C to D. What is it that I need to find now? I need to find the height from B to C, meaning that my focus will be on B to C. If I can find that height or the displacement from B to C, I will be able now to add it with the height from C to D. Can we go and find that height from C to D, from B to C, I mean. Now let's look at the information that I have from C to D. I know the velocity at B is equals to 0 meters per second. I know the velocity at C is equals to negative 10 meters per second. Why do I say that, ladies and gentlemen? I say that because now I chose my upward to be positive, my downward to be negative, and the velocity at D, I know at C it must be negative, and also the height must be now negative, which is now the displacement. Right, ladies and gentlemen, let's now look what else do I have. Remember, I only need three variables, and the last variable which I always have must be G, which is negative 9.8 meters per second squared. Now I want to write our formulas. We have now Vf squared is equals to Vi a squared plus 2a delta y, and then I have Vf is equals to Vi plus a delta t, and then I have delta y is equals to Vi plus Vi multiplied by delta t plus half a delta t squared, and then the last formula is delta y is equals to Vf plus Vi over 2 multiplied by delta t. Now these are our formulas, and from the information that I have my velocity at B, which I will call my initial, and I also have my velocity at C, which I will then call my final. And now from this information I can go now and choose the correct formula. I'm looking for delta y a delta y there. Then it says the formula must now be Vf squared is equals to Vi plus 2a delta y. From there, I know my final velocity at c. The final velocity at c is negative 10 squared is equals to 0. And then plus now my 2 negative 9,8 delta y. Remember, ladies and gentlemen, this delta y is from B to C. Is from B to C. And then I know that 10 squared, it must give me 100. And then 2 multiplied by 9,8, it must give me negative 19,6 delta y from B to C, ladies and gentlemen. Then I will apply now my mathematical gymnastics to say now, let me divide by negative 19,6 both sides, and then that will be able to give me delta what? Delta y from B to C. And then I will then put this into the calculator to say 100 divided by negative 19,6. Then it gives me delta y, which is negative how much? Negative 10,248 meters. Then my displacement, which is a vector quantity, it says it's 5,10 meters downwards. But we know that the examiner wanted now the height. The examiner wanted the height, and then the height, we know that the height is a scalar quantity. It's a scalar quantity. The height will now be 5,10 meters. But now remember, we said the height above the ground, it must be the height of BC plus the height of CD. Then it says to me that the height above ground, must be equals to the height from BC plus the height from CD. What is the height from BC? It's 5,10, 20, 40, 816 plus. Remember, we found the height from BC. What was the height from BC? This was the height from BC. It says to us it must be 15,306,122,45. Then I must add the 2. Remember, height, ladies and gentlemen, it's a scalar quantity. That's why I do not substitute now the directions. Then it will then say 10, 20, 40, 816 plus 15,306,122,445. Then the height above ground reached by the stone will be 20,48,163,27. Therefore, height above ground will be 20,41 meters. Then this, ladies and gentlemen, will be my height of the stone above the ground. I hope we are still following, ladies and gentlemen. Let's look now at the other question that the examiner can ask. The examiner can further say calculate. This is question number 3. The examiner will further say calculate the time taken to reach to reach the maximum height. The examiner can further go on and say, calculate the time taken to reach maximum height. From maximum height, I will then go back to my trajectory to see, for me to reach maximum height, I must move from point A to point B, meaning that my focus will only be now on the motion from A to B, maximum height. Remember, maximum height, they hide a variable there. They hide our variable. By saying maximum height, there's a variable that they are hiding, and the variable at maximum height is that we must know the velocity must be equals to 0. Ladies and gentlemen, let's go and look now at our motion from B to C. It means my focus now on this particular question will now be from A to B. You must show the examiner that you are now focusing on the motion from A to B. But what is it that I have at A to B? I know I have the velocity at A, which is equals to 10 meters per second. I also have now the velocity at P, which is equals to 0 meters per second. Because now my upward motion is positive and the velocity at A, this is where now the object goes upwards. So my velocity at A, you will agree with me that from our choice of direction, the velocity at A must be positive. Then I will assign the direction then to say the velocity at A is equals to 10 meters. And then my G, ladies and gentlemen, you'll agree with me that if upward is chosen as positive, and now we know that G acts downwards, my G will have a magnitude of negative 9.8 meters per second. So my direction of G will be negative and the magnitude will be 9.8 meters per second. And remember from our steps, we only need three variables to help us now to find the other variable. The other variable that we are looking for here, it's the time. It's the time taken to reach maximum height. So that time there, we then look at our formulas. Our formula must have time. Let me include it here to say I am looking for the time taken to reach what? To reach maximum height. So from my two formulas there, the formula that has now my final velocity, which I will take as B, my initial velocity, which is the velocity at A, it then says to me my V final will be V initial plus A delta T. Now remember my V final. My V final is the velocity at B, which is 0 meters. And then my V initial is a positive 10 plus my A is negative 9.8 multiplied by delta T. Remember that our time cannot be negative. Time is always positive because it's a scalar quantity, and we know that all the scalar quantities are positive. From there, I will then have to perform my mathematical gymnastics, meaning that I will transpose this a positive 10. When it gets to the other side, it becomes the negative, and then this side I'll be left with negative 9,8 multiplied by delta t, and then again I will perform my mathematical gymnastics by dividing by negative 9,8 on both sides, and then the time there, as you can see, it's already positive, meaning that I'm on the right track. To say now, let's put this into the calculator. Putting this into the calculator will be negative 10 divided by negative 9,8, and then I will find my time. The time it took for the stone to reach maximum height, it's 1,02040816 Then I will say therefore my delta t is equals to 1,02 seconds. This, ladies and gentlemen, this time, it's the time that now this ball took from A to B. Ladies and gentlemen, the time it took to reach maximum height. From my trajectory, I can see that this is the time from A to B. Ladies and gentlemen, this will now be my time. This will be my time to reach maximum height. I can further go on and see this is the time from A to B. Ladies and gentlemen, I hope now we are still following. And then the examiner can further go on and see, find the time. The examiner can further go on and say, calculate the time, time taken to hit the ground, time taken to reach the ground. Ladies and gentlemen, this will be my last question on this. I will further do on a video whereby now we'll be now doing the graphs, because I can see now the time is against us. It only permits us now to record for only 1 hour. But now let's look at this. The examiner wants the time taken to hit the ground. It means now the time taken to hit the ground. When we look at our trajectory, the time taken to hit the ground, it must be the time from when the object was projected upwards and then reaches maximum height, passes the point, and then hits the ground at point D there. Now, what can we do? How can we approach this? Remember, in the previous question, I just found the time from A to B, and when we drew our trajectory, we talked of now the time. We know that the time from A to B is equals to the time from B to C. Ladies and gentlemen, when we are still analyzing there, we talked now that the time from A to B is equals to the time from B to C. Then, ladies and gentlemen, when I want to find the total time, the total time, ladies and gentlemen, is equals to now the time from A to D, and the time from A to D is made up of now the time from A to B plus the time from B to C plus the time from C to D. But ladies and gentlemen, already I have found the time from A to B, and also I have found the time from B to C. So my focus will then have to be now on finding the time from C to D. And then when I look at my trajectory, my trajectory says I need to find the time from C to D. And then I know the velocity at C. I also know the velocity at D. Remember, I only need 3 variables. So my focus in this question will be from the motion from C to D. Motion from C to D. What is it that I know? I know the velocity at C. I know the velocity at D. Velocity at C, I know it's negative 10 meters per second. Why do I say negative, ladies and gentlemen? I say negative because now my choice of direction we took up as positive, meaning down will be negative. So my velocity at D, I know that from the statement they gave it to me as 20 meters per second. So my motion, my velocity there will be 20 meters per second, ladies and gentlemen. And then I know that I have G, and G must always now be negative 9.8 meters per second. Why? Because my upward is positive. And then from there I can be able now to use this formula that says Vf is equals to Vi plus E delta T. Remember this delta T, ladies and gentlemen, it is from C to D. It is from C to D. And then my final velocity there is negative 20 is equals to negative 10 plus a negative 9.8 delta T from C to D. From C to D. Now I'm left now with applying the mathematical gymnastics to say 20 plus 10 is equals to negative 9.8 delta T from C to D, ladies and gentlemen. And then I know that negative 20 plus 10, it must give me a negative 10 is equals to negative 9.8 delta T from C to D. Ladies and gentlemen, I hope we are still following. And then from there, I will then divide by negative 9.8, negative 9.8. Then my delta T from C to D will now be 10 divided by negative 8, which is now again 1,002,04,08,163. Now remember, we also found that from the time taken to reach maximum height is the time now it takes this particular object of mine to reach now, to move from point C to D. Remember, there are still formulas that we can use. You can also now use this formula or use formula number 2. You will see now that the time will still be the same. Right, ladies and gentlemen, let's move on. This is time from C to D. the time from C to D. Remember the total time from A to D is equals to time from A to B plus the time from B to C plus the time from C to D, meaning that our time from A to B, we found that, ladies and gentlemen, to be the same value. So we can simply say now this is 1,02 and 0,408163 plus 0,12408,163 plus 1,020408,163, and then this is just simply saying now let's multiply this by 3. So the total time it took, it's now 0,622,449. So time from A to D, ladies and gentlemen, is 3,06 seconds, and then that will now be our total time. I will then record another video on the graphs. I'll record the other video on graphs, and then we'll look at that. Please, ladies and gentlemen, where you have a question, don't be afraid, just simply ask in the group there. We looked at type 3. This example will help you now to do the worksheet that I gave you yesterday. Ladies and gentlemen, we'll see each other soon.